Welcome back to the hyperbolic detention chamber. We are back once again. The microphone stand is here, so there should be better sound, but it'll probably start with tomorrow's video because I'm out of brain power to set it up. That being besides the case, Elon Musk recently joined the Discord, so you're going to want to join the Discord to chat him up about things pertaining to rocket, space, and general off-planet activity. So, just joined. We were waiting for Big Bro to join for a minute, so glad to see that he's finally in Discord. And yeah, just pretty cool to see. We're also instituting a new rule. This is the hyperbolic training chamber. So after each completed problem, we're going to do 45 push-ups. So after I complete a problem, or after you complete a problem, you can @ me in the Discord, and I'm going to send. Okay, you'll know that I did it. Just trust me. I definitely do it if you send it to me. So starting today. So that's what we're going to do today. I'm a little bit sick, but something I'm not sick of is the comments. So we have some more comments from the legendary ADC skateboarding aficionado, part-time entrepreneur, YouTuber, software engineer, and general all-around good person. Sylvia Plath, you did it again, Twiz. Truer words never spoken. And this butterfly emoji, she stay on it. Yeah, I mean, she actually had a pretty tragic death, but her work will forever be lived on, and it's actually pretty epic that people still know of her, so that's pretty cool. So appreciate the comment. We also have Thomas Wong, part-time entrepreneur, finance whiz, quant, day trader, stockbroker, professional bank account increaser, the legend, the man, the myth, and the parable. Haven't checked in for a while. LeetCode's new UI is hopeless. True. Is it hopeless, or do we hate change? It's hard to know, and we may never know. And I'm thinking for myself, it's probably a bit of both. So yeah, the new UI, it's cool though that you can switch between submissions without the page reloading. So that's pretty cool. And you can also switch between some of the, I think, portions of the problem without the page reloading. So some pretty cool spa action or single page activity. Application. And then we have glad to see you, big bro. And then we have Peter Peterson, an absolutely real person with on their driver's license. It does indeed say Peter Peterson. So this is true. I've seen the license. And I really enjoy your work ethic. I got my tasking yesterday and working on a bigger project right now. Let's go. So Peter had his task to complete yesterday. It has been completed, and thus, so we can continue the train of momentum in the hyperbolic coding chamber, I will also try and complete our task today, which is that of the LeetCode journey. So always good to see the motivation and discipline ball rolling. We up next. Feels strong, man. Feels strong. So yeah, we have more LeetCode to do. But yeah, after the problems, I'm going to try and get in some reps. So if we solve a problem, I'm just going to hit like 10, 15 reps real quick of push-ups. So maybe that'll be the wave, and we'll see how far we can get with that. You know what? How about every problem we'll solve? We'll try and, yeah, because I remember checking out the Atomic Habits book, and one of the legendary ways to build more habits is to chain new habits you're trying to build on top of the habits that already work. So we're already going to be doing LeetCode every day, so we might as well chain some health activity in there. So might as well. So we'll try and do it. Maybe we'll be jacked by the end of the year. I used to lift, but we fell off. Once LeetCode started getting into action, we fell off. And actually, I used to lift pretty regularly, but then I started rowing to fix cardiovascular health, and it's kind of hard to have the energy to both row and lift. So I've just been rowing, to be honest. So kind of fell off there, but hopefully we can do better. Hopefully we can do better. So that'll be pretty cool. But yeah, so we're going to do based on chaining. I think it's called chaining. We're going to try and chain some more habits into it. So I'm going to try and chain some push-ups into it. Fortunately, we don't solve many problems a day, so this is kind of just an elaborate way to not do the habit anyway. So we'll try and do it, and then yeah, I've been playing with around some ideas. I think we're going to try and do another daily thing. Could be cool, could not be. I'm not sure if I can handle the load, but maybe we can actually. I'm going to try another daily thing. I'm not certain what it is yet. Actually, I think I know what it is yet, but I need to figure out a way to do it that makes sense. But I think it'll be pretty cool. And yeah, I'm starting to think maybe daily habits are the way to go. So maybe that is the future. Maybe that's the wave. So for some reason, daily thing seems to work well with my psyche. But it could also just be, I think it seems like if I can automate failure on a task, then I'm okay doing it. So that's pretty much the goal. And yeah, I think maybe we have more information about that soon, maybe, or maybe not. What we do know, what we're not unsure about, is that you should join the Discord. The Hyperbolic Coding Chamber needs you. There are tons of people in there chatting. I think Elon's in Discord right now. He's doing one-on-one, just business entrepreneur sessions. So if you want to join the Discord and just chat him up, you can like, we gave you the secret cheat codes. We also have tons of other competitive programmers in there giving tons of tips. One question we had yesterday was, how do you know if you did good on an interview? You know you did good on the interview if the interviewer daps you up after. So just some tips and tricks like that you're going to want to know so that you can do well. So we're going to jump into the LeetCode. And yeah, we're going to do an hour as per usual. And hopefully we can stay focused. So here we are with an hour of work to be done. An hour of work in the Colosseum fighting against and for our ancestors. So gonna do an hour. So here we are. Minimum cost to move chips to the same position by Adobe, Bloomberg, and Amazon. We have n chips where the position of the ith chip. We have n chips where the position of the ith chip is position sub I. N chips, the position of the ith chip is position sub I. We've seen another problem like this before. So I have n chips and the position of the chip is given by position sub I. We need to move all the chip, and I guess the number of chips we have is actually position.length. We need to move all the chips to the same position. In one step, we can change the position of the ith chip from position I to either position I plus 1 or position position sub I plus 2 or position sub I minus 2 with cost equals 0. Return the minimum cost needed to move all the chips to the same position. I'm trying to visualize it. We have position of chips. We need to move all the chips to the same position in one. We need to move all the chips to the same position. In one step, we can change the position of the ith chip from position sub I to position sub I plus 1, position sub I plus 2, position sub I minus 2. Position sub I plus 1 or position sub I minus 1 with cost equal 1. Return the minimum cost needed to move all the chips to the same position. We should just look at the diagram. Maybe I spend too much time visualizing. position dot length chip, so 3 chips. Okay, so let's read the example. Position is equal to 1, 2, 3. So you have 3 chips. And we can change the position of the ith chip from position sub I to position sub I plus 2 or position sub I minus 2 if cost equals 0. Yeah, the position of the ith chip is position sub I. Position of the ith chip. Oh, I see. So the okay, I should just read the diagram. In one step, we can change the position of the ith chip from positions of I to turn the minimum cost needed to move all the chips to the same position. You can move 2 steps for free, but you can move 1 step. You move 2 steps for free, but to move 1 step, you need to move the cost. Yeah, it costs money to move 1 step. So the cost here is 1. I see. Now I'm trying to figure out what the values in the array actually stand for, because right now it seems like they're kind of useless aside from the frequency. Position sub I. Position of the ith chip is position sub I. So this last chip is at position 1 something. Right, so the literal value in the array is the position. So if that's the case, my question is, how can you move from 1 million to 1? I didn't explain this last one. I think we could solve this, but I guess I need to know why. Position sub I plus 2. Oh! Okay, I think we could solve this. I think we just need to get... I see why. It's because to get from 1 to this large number, you would just go 2 steps, 2 steps, 2 steps until you were 2 steps away. And then you would get 1 step, which it costs. So it seems like we need to figure out the position with the highest frequency. If we figure out the position with the highest frequency, then we just have to move all other instances, all other chips that are not at that position. We just have to mod them by 2 and add the remainder to the output. So I think if we do that, I think the one issue is that actually the list isn't sorted. I guess in this case, both numbers have an occurrence of 1. And so if we choose our number to be, let's just say 1, right, we'll ignore the one that we're currently at. Actually, yeah, now I'm realizing it doesn't really matter. We're only using the number, the highest frequency position, to figure out what numbers to ignore. So let highest, we'll say most common position. I guess, yeah, we'd have to load it into a map. So we'll just create a map of number to number, and then we'll iterate through the array pos of positions, or of position, and we'll say value is equal to, if we already have the value of the position in the map, right, then we'll get that value of the position. Otherwise, we'll set it to 0. Then we can say map.set pos value plus 1. From here, we can sort it. I think we can sort the map based on key value pairs. Oh, wait. You should be. I think you can because it's an iterable. And then we'll just sort it based on the. We'll sort it in descending order based on the value. For some reason, I'm not getting any syntax, or like, usually it tells you what's wrong. Let me refresh the page. I guess you can't. So I guess what we'll do is we'll just load it into pairs, and we'll say map.sort. And then we'll just print the pair. So we'll destructure the pairs into an array of tuples, which will sort based off the value. Actually, here we should get 2, right? And so the most frequent number, so we'll say most frequent or most common position will be equal to pairs sub 0 sub 0, and then we'll iterate through all positions again, and we'll just do min cost plus equal pos mod 2. If pos does not equal, actually no, now I'm realizing it doesn't even matter. You actually don't even have to check, because the most common position, actually no, it does matter. If we did this, we take 2, and we should do pos mod 2 and get 2 here. Should pass this one. What we'd get for this is 1, so we'd ignore 1, and we'd do 1000 mod 2 and get 1. And for this one, I'm worried, but you should just get, if they're all equally frequent, then you should be able to move them all to one position. Excluding the most common one, so we'd move it once here, move it 2 down, and the output should be so 1 moving to 2. Interesting. I don't think this is gonna work to pass all the test cases now, but I think it could pass all the test cases if we do it in n squared time. So we'll try this version first, I guess. Oh, 1 mod 2 does give you 0. Hmm. Using 1 billion. What would this be? 1 million? Yeah, 1 billion. $1 billion. On 1,000, I mean 1 billion. Maybe we can skip all this nonsense completely. Ah. You still end up with 0. I think the maximum cost that we can have is position.length minus 1. I think we need to use a regular loop. We'll change all this stuff from outer to inner. And then we'll only do this inner portion if outer does not equal the same index of inner. Wait, I think it can't be mod 2. Just blank. So if we do 2 mod 2, we get 0, but you have to move 1 position down. What if I'm trying to do is 2 mod the most common position? That's not it either, though. I think it's 2. I think it's the position 2 minus 1 mod 2. Position dot length minus 1. Outer does not equal inner. We'll skip all this stuff. Oh my god, the problem is up here with min cost. I should have ripped. Position dot length minus 1. We'll do position sub inner minus position sub outer. Absolute value, get 1. Mod 2, you move 1 down. But let's just say we deal with 2 now. Mod 2 gives you 1. That would give you 2. 2 to move up and 1. So we should be getting 1. Right, but if we're doing mod 2, actually, we don't need to do it like this. Can we just set min cost to infinity? And then we could just go back to adding. Ah, that was bad. That was really bad. I got confused and then I did a lot of extra stuff. We should have read through the problem more carefully. I think we could still do better than n squared time. We go back to our original version. We'll do for const pos of position, and we'll say if pos does not equal most common position. Does it even matter? If you subtracted them and modded them by 0, you would still get 0. So it doesn't look like it matters. Now, if we subtracted them, I think the only part that kind of sucks is that with this one here, we can have multiple pairs be tied. Multiple pairs be tied for highest occurrence. And I guess you could just take the one that is closest to the center. Then we could do most common positions dot push k. Then we'd have the most common positions. From here, we just need to take the one that's closest to the center. That's closest to the center. Actually, no. Couldn't we just say that the most common position is equal to most common positions? Pretty much you want the one that's always closest to the center. If we took the length of the length of the array, let's just say it was 10. You had 1, 4, and 9. So I will give you 1. Ten minus 1. You know what? I think we'll take it and see how they got here. No. Oh, this is what we said in the beginning. No. Oh wait, never mind. This is not what we did. Though marked as easy, this problem is a little tricky and requires some observations and insights. It's recommended to try a few examples to find out some regular patterns. Moving chips cleverly. Notice that we have two types of costs. Cost sub 0 and moving to position sub I plus 2. Cost sub 0, moving to position since move to position I plus 2 or I minus 2 is free, it's actually thing that first moving chips as close as possible. 0 cost. In fact, we can move all chips at even positions to position 0. Move all chips at odd positions to position 1. Then we only have many chips at position 0 and other chips at position 1. Next, we only need to move those two piles together. Given two piles of chips located at 0 and 1 respectively, intuitively it would be less effort taking, less cost to move the smaller pile to the larger one. Interesting. That was a good problem. It's interesting because it presents very presents with a lot of complexity, but with some thinking there, can be simplified. It's very interesting how they got there. I simplified it, but I went with a different route. I would have never figured out the even versus the odd count thing, even though we got the even one. So that is very interesting. So here we have 953 verifying an alien dictionary. I think this was linear. No, this was n squared time. And I think the sorting algorithm actually takes log of n space in JavaScript. In an alien language, surprisingly, they always still use English lowercase letters, but possibly in a different order. order of the alphabet is some permutation of lowercase letters. The order of the alphabet is some permutation of lowercase letters. Given a sequence of words written in the alien language and the order of the alphabet, return true if and only if the given words are sorted lexicographically. Given a sequence of words written in the alien language and the order of the alphabet, oh, that's actually really clever. Return true if only if the given words are sorted lexicographically in this alien language. The words are hello in LeetCode, and the order is this. And it is stored sorted lexicographically. This is false because D comes after L. All right, we're putting L before D. This actually makes sense. I think what you could do here is just, well, is order always 26 length? Okay, our English lowercase letters. I think you could literally just map the order in this alphabet to a map, to map it to its index it should be. Then you can just iterate through every string and check that its mapping, or its alphabetical mapping, is less than or equal to the next letter. So we'd have hello, H is less than or equal to what E maps to, and E is less than or equal to what wait a second. Oh, if the words are sorted lexicographically. Interesting. Well, let me test one thing. We have HEL and we have HELL. And we'll just return true. Right. Let me make one more test here. If we use something like, if we use something for the first test case, or whichever one, yeah, something like HHH and then A, or actually B, HHH should come before B. Interesting. And if I add A here, or if I, why can't I click here? If I have HH here and we have B, if I add one H, we should get HHB. So our output oh, right. Well, we'd have to give it the correct order first. If I say H, 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 B, we should get true. Okay, so I think we should be able to do this. I think we just have to map the characters to numbers, and then we'll give each word in the array a score, and then we'll sort it, and then we'll compare to see if they match. So to do that, we have to first iterate through the order. We'll say const letter of order. We'll actually say let I is equal to 0. I is less than order.length. I plus plus. We'll say map.set order sub I to I plus 1. This is because the first letter in the alphabet, which is H, we want to have a value of 1, so that 3 H's gives you a lexicographical value of 3. Make something called lexico, which will copy the words and then we'll map through it. I have something called value, which is going to be set to 0. We're just going to iterate for let letter of word. We're just going to do for each letter of the word, we're just going to do map.get letter, right? And then we're going to say value plus equal map.get the value for the letter. From here, we can sort lexico, right? And we'll sort it A sub 1 minus A sub B. And we're just going to say that this is an tuple of a string array and a number. And then I'm just going to print lexico for now. Oh, and this is going to be an array of them. Oh, not a string array. Ah. So we can check if we're on the right track here. Word, world, and row. They output true here, so it is lexicographically sorted. So word is first, is second, and row is last. So maybe what they actually want is B minus A. World, word, and row. If we check case 1, we have BAHH. Uh-oh. HHHB. So Maybe this isn't what they want. Oh no, I was getting messed up. They wanted false, so we're good here. Here we have HHHB, and they were true, and we're giving, and yeah, okay. And the final one, apple and app, should be false. So for here, we can just say for const, we can just say let I is equal to 0, I is less than lexicode.length I plus plus, and we just say if lexico sub I, right, sub 0, which is the word, does not equal words sub I, then we'll return false. So I output false, and they return true. I guess in the case where they have the same score, no, we have QUVP gives you a score of 45, and K gives you a score of Q gives you a score of 12. If you sort that, you would get 12 and 45. So we return false. Maybe this is probably not how I think we could change this. We can keep the map of the order of the strings, the map that we're using, and just maybe define a comparator like less than or equal to. It also feels like a sorting implementation problem, because if you you just have to swap the comparison function out for a comparator that uses lexicographically sorted strings instead. KUVP. Q is 12, KUVP is 45. Q equals 12 and KUVP equals 45. I think we can comment out all of this. We'll copy the words as we did earlier. We'll spread them into the lexical array. We'll swap this out for compare A and B. And then we'll check if we get up with the same answer. The only thing we have to return is the comparison, which will take a string A and a string B. It's going to return a number. The other thing it's going to accept is the alphabet, which is going to be a map of string to number, and then we'll pass that in up here. And what we're going to do is compare the strings. So to compare the strings, we need to know the smallest to A dot length less than B dot length, and the smallest is A. Otherwise, the smallest is B. And longest, it would be equal to, if shortest is A, right, then longest would be B, otherwise it would be A. So in this one we can say I is equal to 0, I is less than shortest length, I plus plus. You can say if string B you can just say map.get B sub I, right, is greater than map.get A sub I. We called it alpha. And we'll just return 1, saying that string over the shortest string, and we'll pretty much say if if we get the value for B and it's greater than A, then we know that B is greater than A, or it should go later than A. Else if alpha.get A sub I is less than alpha.get B sub I, then we'll return -1. If we make it to the end, right, because when they're the same, we're pretty much going to ignore it. If we make it to the end, right, it would mean that they're at least the same length, or they at least share the same prefix. So what we return, if they share the same prefix, so if A dot length equals B dot length, means they share the same prefix. If they're the same length, it means they're the same string, so we'll return 0. If they're not the same length, then we'd like to return whether A dot length is shorter than B dot length. It might just be easier to say if A dot length equals B dot length, then we'll return 0 up here. Otherwise, A dot length is less than B dot length, we'll return -1. Otherwise, feels like it's almost there. I'm a little... I'm not getting any output, which is actually very strange. Something's off here. I should be exiting out of this at some point. Is H greater than H? No. Is H greater than B? What does it mean to be greater than? It means to be past it. H is not past B. So we have H and B. H is 1, B is 4. H is 1. B is 1. Oh, I'm getting confused. H is B sub I. A sub I is 4. Is 1 greater than 4? No. Is 4 greater than 1? Ah, I think these have to stay the same. If A sub I is greater, is 4 greater than 1? Yes. Is 4 less than 1? No. Oh no, these have to go back to oh, so we'll take that one as well. And we'll remove this. So yeah, the runtime there is kind of awful, but I can't see how you can't not check the order, which is constant time and constant space. Then you copy the words, and you sort them. That's n log n. Then you're having to check the words one by one. Say constant space, maybe log n space for the sort, and log n to sort. This compare function, we also end up doing O of S, which is the sum of all the characters in the string. Yeah, that is an interesting one. We'll stop there.